Okay, welcome back. This is our second trigonometry video. And just before we get started with our examples, I want to make sure we go over the rounding table for the unit. The table compares the precision of an angle with the accuracy of a trig function. This will also be true for side lengths when we start solving right triangles. And so, for example, if you're given an angle and it's expressed to the nearest 100th, then you would show 4 significant digits when you work out the trig function of that angle. Similarly, if you're given a trigonometric function, maybe the sine of a certain angle, and it's expressed with 3 significant digits, when you work out the value of the angle itself, you'll be rounding to the nearest tenth. And the other thing you see on this front page here are the 3 reciprocal functions. So the main trig functions are sine, cosine, and tangent, and then we have cosecant, secant, and cotangent as their reciprocals. Okay, so these are the kinds of questions that you're responsible for. So the title here is Functions versus Angles, and here would be the first kind of question. For the value of, or find the value of the trigonometric function. So the first thing you want to do is make sure that your calculator is in degrees. Okay, so make sure your calculator is in degrees mode. And then, for example, this question says cosine of 47. So we just need to press in cos 47 equals. So this would be our answer here. And then when it comes to rounding that answer, we look at the angle. We realize that it's expressed to the nearest 1 degree. So that would be here in the chart. And so we should be rounding our answer to 2 significant digits. So this number rounded to 2 significant digits is 0.68. So that would be our answer here. Okay, and I'm going to write in brackets that we used a rounding to 2 significant digits. Okay, so here's a second example, cosecant of 22.81 degrees. Now, the obstacle, of course, is that cosecant is not on the calculator since it's a reciprocal function. But since it's equal to 1 over sine, we know that we want to figure out 1 divided by the sine of 22.81 degrees. Okay, so 1 divided by the sine of 22.81 equals, and this is our answer here. Now the angle was given with 2 decimal places, so the angle was expressed to 2 decimal places. Okay, so according to the chart, we need to round our answer to 4 significant digits. So here's the answer on the calculator display. So when we round the answer to 4 significant digits, it would be 2.579. Okay, so I'm going to put in brackets the fact that we rounded to 4 significant digits. Okay, and here's a similar one, secant. Secant is a reciprocal function, so to compute the secant of 7.8 degrees, we have to figure out 1 divided by the cosine of 7.8 degrees. So I can punch in 1 divided by cosine 7.8 like this, right? Or I could do cosine of 7.8 degrees, work that out, and then invert that answer with the x to the negative 1 button. And that will amount to the very same result. Okay? So, the angle had 1 decimal place. It was rounded to the nearest tenth. And so when we write our answer now, we should write down 3 significant digits. So this number rounded to 3 significant digits is 1.01. Okay, so of course we round up here because of the 9 in the hundredths column. Okay, so those are the first things we need to be able to do. Here's the next thing we need to be able to do. If you're instead given the value of a trig function, you should be able to work out the angle theta. Notice we're talking about an acute or quadrant 1 angle for now. Okay, so how do we do this? If we know the cosine of theta is 0.0427, we can work out theta by doing the inverse cosine. Okay, so with your calculator, you can see it right above cosine. So it's this, for the Casio, we go shift cosine and then 0.0427 and push equals, and we get our angle that way. Okay, now I think if you have some of the other calculators, like a sharp calculator, you'll put that number in first and then do shift cosine equals to figure out the value, okay? But with the Casio, it's shift cosine, then put in the number. Okay, so again, depending on your calculator, some of the sharps I think want you to do number in first and then shift cosine equals. Okay, so we get this angle here in degrees. And now, see, we're starting in the right-hand column of the chart with a trig function value. This has 1, 2, 3 significant digits. So we're here in the chart. We're working out the angle. We move this way to realize we should round the angle to the nearest tenth of a degree. So in this case then, that would be 87.6 degrees. Okay, and I'm gonna write in brackets that we rounded to the nearest tenth of a degree. Okay, now again, if you're given a reciprocal function like secant or cotangent, there will be an additional step. First, you have to change it to the main trig function cosine. So that means doing 1 over 2.045 like this. So theta will be found by doing the cosine inverse of 1 over 2.045. Okay, so I'll show you that on the Casio here. So there we go, cosine inverse. And now I want to put this in. So I could either use a bracket with that division with divided by, or I can put this in as a fraction. So if I want to do it as a fraction, I don't need a bracket. I just do 1 over 2.045 equals. So this is the angle here. Okay, so now when it comes to rounding, I'm starting with 1, 2, 3, 4 significant digits for the trig function. So starting here in the chart, we should round our angle to the nearest 100th. So 2 decimal places. So that would be 60.73 degrees. Okay, and I'm going to include as a little note the fact that we rounded to the nearest 100th. Okay, so I'll show you again. If you don't want to use the fraction button, you can do this. Cosine inverse of bracket 1 divided by 2.045, close the bracket equals, same result. And a reminder that again, some of the other calculators, they'll want you to put in the number first. So you would be doing 1 divided by 2.045 equals, and then you would do shift cosine inverse, okay, which actually works on this calculator as well. Okay, so if you have a sharp, I believe they make you do this first. First put in the number, 1 over 2.045. So first put the number in, push equals, and then shift cosine equals. Okay? All right. One last one of this kind. So again, it's not a main trig function. So we start by making it a main trig function. So it has to be made a main trig function so that it is in fact on our calculator. So the tangent of theta is 1 over 0.15. So theta is found by taking the tangent inverse of 1 over 0.15. Okay, shift tangent, and now I can use the fraction button, 1 over 0.15, push equals, and there's the angle. Okay, we were starting with 2 significant digits for our trig function, so our angle should be rounded to the nearest degree. And this will be rounded, therefore, to 81 degrees. In brackets, I'll put that we rounded to the nearest degree. Okay, and again, if you prefer not to use the fraction button, you can do this. In a bracket, 1 divided by 0.15, close up the bracket, 81 degrees. Okay. Let's consider a couple other problems. Look at this question. It says, find the cosine of the angle given that its sine is 0.6725. So we can solve this problem if we begin by figuring out the angle theta first. So we start with the fact that we know the sine of the angle. So if we know the sine of the angle, we should be able to figure out the angle. The angle will be the sine inverse of 0.6725. Notice we're not doing any 1 over business, and that's because sine is on your calculators, right? The only time, if you look, the only time we had to do 1 over, 1 over, 1 over, 1 over is when the original function, cosecant, secant, secant, and cotangent, they were reciprocal functions. They were not one of the functions on the calculator. Okay, so when you're given sine, cosine, and tangent, you will not be doing any 1 over. So anyway, we start by getting the angle itself. So we would do the sine inverse. Inverse sine is done this way. Shift sine, right? Sine inverse of 0.6725. And that gives us our angle. Okay? So the original function has 4 significant digits. So when I write down the angle, I'm going to write it down with 2 decimal places, 42.26 degrees. But I'm not going to clear the calculator, okay? Because it's better to use the whole answer here. Because now that we have theta, we want to know its cosine. So the cosine of theta is simply the cosine of this angle. So I can do cosine equals, and now I have the correct value for the cosine of theta. And it's a trig function, so it should be rounded like the given trig function, which means 4 significant digits. So 0, the leading 0 doesn't count as significant. 0, 7, 4, 0, 1. If we round to 4 significant digits. Okay, so the given trig function had 4 significant digits, so our trig function answer should also have 4 significant digits. Okay, let's do one more that's a little more involved yet, because here at least these were both main trig functions. In this example, they're both reciprocal functions. But again, the first objective is to find theta. Just like we did here, you have to start by finding theta. So let's start with what we're given. We're given the secant of theta. Secant is no good to us because it's not on the calculator. So first step, change it to cosine by doing 1 over 9.407. This means we can find the angle by doing the cosine inverse of 1 over 9.407. So we begin like that. Okay, so cosine inverse, and now 1 over 9.407 equals, and we get this for the angle. So 4 significant digits for the trig function. I'm going to write down the angle with 2 decimal places, and that, when I round, is actually 83.90 degrees. Okay, but I don't want to clear this. I want to be able to use this whole quantity because now I'm going on ahead to find the cosecant of this value. So how do we find the cosecant of this value? Well, we have to remember that the cosecant of the angle is going to be 1 divided by the sine of the angle. Okay, I can actually put the actual angle in degrees here. I think it might be even more clear. So we're trying to figure out now the cosecant of 83.90 degrees. So we're doing 1 divided by the sine of 83.90 degrees. All right, but again, I'd like to be able to use this unrounded number in this calculation. So I can use the answer button, I think. So if we clear that and we go 1 divided by the sine of the answer and push equals, we'll get this as our final result. All right, and this number should be rounded to 4 significant digits like the original trig function. So it would be 1.006. Okay? All right. See, if I just punch in 1 divided by the sine of 83.9 instead, I'm going to get the same result. Okay, so there would not be a rounding error in this case to worry about, but sometimes there might. So that's why I kind of like using the answer button in an exercise like this. But if we go over it then, we started with cosine inverse of 1 divided by 9.407. Okay, and that got us our angle in degrees. And then to work out its cosecant, we just wanted to do, so I cleared it, 1 divided by sine of that answer. Okay, so it's a nice option, but it's not completely required for you to use the answer button. Okay, And this is now correct to 4 significant digits. All right, so in the lesson today, we concentrated on the difference between angles in degrees and values of trig functions. We practiced using this rounding table in order to move seamlessly between angle measures and trigonometric function values. All right, so I've got suggested problems from your textbooks listed in Blackboard for you to try. Okay, great. Next time we meet, well, when I say meet, I guess it's in the next video, you're gonna be watching me solve right triangles. So we'll spend a couple of videos looking at solving right triangles. Okay, thanks. Have a good day.